Hello everyone and welcome to How Much is Too Much
Hi.
from the Advanced Maths Support Programme. My name is Kath Moore and I'm one of the central coordinators, and presenting with me today we've got Ben Sparks. Hi Ben, tell us a bit about yourself.
Hi, I'm Ben Sparks. I work for the AMSP as well, but then you probably figured that out. We are here doing some maths. We want to share a cool bit of maths that we want to make sure that you guys get to experience in the classrooms or at home, depending on where you are. And people will be watching this recording from lots of different places. There will be some interaction. There'll be a chance for you to get involved, and it will depend where you are, how you can interact on this recording. It's also a recording, so you won't be able to interact live, but there are ways you can get involved in the experiments we're going to try. So the more you interact, the better for you. Kath, why don't you give us an outline of what the plan is?
Yeah, of course. So we're going to play a game and Ben and I are going to demonstrate that game for you, and then it's going to be your turn to play the game. And at that point, we'd suggest that you pause the recording so that you've got time to play the game. We'll come back afterwards. We'll talk a little bit about some of the strategies that you might want to do. We'll talk about how we can gather some results, and we'll then give you maybe a final challenge to think about. So Ben, shall we start by demonstrating the game that we're going to play?
Yeah, it was all sort of inspired by this thing. I don't know if you can see it on the camera. I'm actually going to share a screen here. This is a game called Pass the Pigs, and I've just thrown the pigs on the floor, which is very exciting. But let me give you an image of this game. I played this when I was really young. And I loved it. The game involves two plastic pigs. I'm holding one up to the camera here as we speak. It's very exciting. It's got a little dot on one side, not on the other. It's not a complicated game. You throw the pigs on a table and you score based on how they land. And so it's simple enough for young me to figure out. But it was also quite interesting because the catch was you could roll as many times as you liked. You could keep rolling these pigs, keep scoring points. But one particular roll, which I think on this one is called a pig out at the top here. I don't know if I can get my pointer on this one here, meant you lost all your points, and then you had to pass the pigs on to the next player, which is where the name Pass the Pig comes from. Clever stuff. And the game was just get as many points as you can, and you had to choose to bank your points at any point before you lost them. So we're going to play a simpler version. Kath, are you up for joining in on this?
Yes, I don't have any pigs though, so how am I going to play?
We're going to play with a die, or as they call it these days, a dice, a D6, in fact. And to aid this, I have got what they call the dice cam ready. You ready for dice cam?
I'm ready for the dice cam.
Dice cam is here. This is a live dice. I'm not cheating. It's just a die in a bowl. So this is a very easy game to play at home. And the rules are very simple, Kath. You get to roll the die, just like with the pigs version, as many times as you like. And every time you get the points that you roll on the dice. Okay. And you just keep adding them together until you can score lots and lots of points. Unless at any point you roll a 1, in which case you lose all your points that turn. So your turn will come to an end either when you roll a 1 and you'll get 0 for that turn, or before you roll a 1 you need to say bank.
Okay, that makes sense.
Those points will go into your bank. They'll be safe. They won't get lost later on.
Okay, now I think it'd be quite a good idea to write down what we're scoring as we go.
It would be very good idea.
What I've got here is a worksheet, and it's entirely possible that your teacher has passed this on to you. But if you haven't got a worksheet like this, but you've got a piece of paper, then you can do the same thing. Now, we're playing with 2 people, but of course, if you're on your own, maybe you haven't got anyone to play with and you're watching from home, you can just play this game by yourself and see what your total score is. Don't cheat. So you just need to record. What we've got here is a column for recording the score for that turn, and then your cumulative total as you go down. Now this only goes up to 5. You might want to play it for a bit longer, but should we have a few
I think we should do a demo,
a few turns and see how it goes, Ben?
Right, you're going to go first.
Okay, all right. Could you, because you've got the dice there, roll the dice for me, please?
Rolling the dice. You've scored 3 points.
Fantastic. Could we roll the dice again, please, Ben?
You could bank it if you want to.
I could bank it, but I think I'm going to roll the dice again with that.
You're going to roll again. Okay.
I'm going to roll again.
You've got 4 more on top of the 3 you already had, so
that
you
makes
would
7.
Be on 7. Yes.
Yep,
do you want to roll again? Or
yes, please. Please roll again.
Okay. You've rolled a 3, so you've got 10 altogether.
10. I'm going to bank on that, so I'm going to make a note that because it's my first go, of course, my score for that go is going to be the same as my total score. Shall I keep a record of your scores as well, Ben?
Please do, Kath. I'm going to go now. I've scored 3. I'm going to roll again. 6, nice. 9 altogether. I'm going to roll again.
Nice.
Another 6, excellent. This is 15. I'm going to roll again. I can't.
Sorry.
Can't say rude words on the recording. I got a 1, which means whatever I was on, I've lost everything, and my turn is over because I was greedy. Some people call this game Greedy Pig. The original game, by the way, is the dice game, and it is called Pig, which is possibly why Greedy Pig got sort of tagged together, and why they called it Pass the Pigs. Anyway, I'm just covering up for the fact that I just lost all my points. Kath, your turn. Do you want to go again?
Yes, please, because I'm in the lead. So
Okay.
let's roll that dice.
3.
3. Can we roll the dice again, please?
Yep. Another 3. 6.
Can you roll the dice again, please, Ben?
I can roll the dice again. Another 3. What are the chances? Don't answer that. 9 altogether.
Ooh, can I roll it one more time, please, Ben?
Yes.
Maybe I want to roll it. Definitely roll it again.
Another 3. That's amazing. So you got 12.
I am definitely going to bank 12.
Okay.
So I am going to
12 goes
score 12
It's not looking
and
good.
giving me a total of 22. So you
I
can
see.
see
So
how
that column's the running total of everything you've got that's been banked.
Yes, that's right.
Okay, I'm going to go again.
All right.
Try and get off the mark here. 4. I'm going to go again.
Fantastic.
2 is 6 altogether. Another 2 is 8. Plus 5 is 13. I'm going to bank on 13.
Bank on 13. Okay. I think we should play another round of this, Ben.
Okay, one more. So like a turn each. Go for it. Go. Your first roll is 3.
And again, please, Ben, roll it again.
That's a 1. You lose that.
Oh, no. So this go, I scored 0.
Yeah.
But I've still kept the 22 that I had from before.
So the stuff that you've banked earlier is safe in the bank. Okay.
Yeah.
So if I'm playing against you, I might be now trying to beat your 22, but maybe in another life I'd just be trying to get a biggest score as possible. Let's see what happens anyway. I've got 6. That's a good. I like 6 and 1. Okay, that's not good.
Oh. Okay.
So that's not a 0.
Look, you got 13 there, Ben.
Thanks. Lucky for some. So that's the game. The game is pretty simple, but it's not obvious. At least it wasn't obvious to me how to play well instantly. And I think everyone just needs to have a play. What do you think, Kath?
I think so. So what I'd suggest then, folks, is that you have a go at playing this. Now, it's possible that you're at home, maybe you don't have access to a dice, but there's going to be a link coming up on the slide in just a moment. And you can go to, if you look just down the bottom of the slide there, there's a link here so that you can get a virtual dice from there. So you can play with, even if you don't have a dice in front of you. So it's just maybe 10 turns while you're just getting used to the game and then thinking about, oh, when should I bank? When should I not bank? Okay.
In particular, you don't have to play against someone else, although sometimes it helps to have another player if there is someone nearby to play with, keeps you honest, stops you cheating and all that stuff. We are going to get some real data from you in a moment, but this is just have a chance to get to know the game, maybe 5 minutes, but do at least 10 turns if you can. Anything else, Kath?
I don't think so, except to say, do remember to pause the video.
Yeah, so now pause the video, otherwise we're going to keep talking about all sorts of stuff. I'm going to give you a chance to play. So pause now, and we'll see you in a moment when you unpause.
Welcome back. And if you forgot to press pause and so you haven't had a chance to play the game yet, then press pause now. And if you have played the game, then that's great because we're going to talk about some of the strategies. So what sorts of strategies do you think, Ben, people could have used if they were going to play the game?
It's a weird one, this, isn't it? Because it's such a simple game and basically you just want to score high. So the strategy is get as many points as you can before you lose them. So I think the best strategy is to roll until you lose all your points and then quit a turn earlier. Unfortunately, unavailable to the mortal person. The next best strategy that occurs to me, which I also don't like, by the way, is like just roll until you feel unlucky or possibly lucky. Because if you could predict what you're about to roll next, you would know whether to bank. This is a bad idea.
Doesn't seem like a very safe way of playing it.
And yet everybody who plays a sort of a luck game where there's like will feel that temptation to say, oh, I feel lucky. What I'm trying to say is that I think there's a better way to play. Now, one thing I was trying, and if you watch what I did, it didn't work out so well, but I was actually trying to stay in for 4 rolls before I banked. And the first time I think it didn't work. I just lost everything. Is that right?
You did actually. Yes, Ben. Yeah.
The second time I did get some points.
Yeah. You got 13.
The third time I lost everything. Now, I'm not saying, actually, I was trying to stay for 4 rolls. I'm not saying that's a bad strategy. It just didn't happen to work out. The trouble is, now I think about it, a roll strategy doesn't feel like it allows me to compensate for whether I'm doing well or not. If I'd rolled 4 6s, I'd be like, yes, I really need to bank now. But if I'd rolled 4 2s, I'd be more tempted to stay in because I haven't got a good score yet, and my strategy would be to still bank then. So did you? I think there's probably better ways to play. What were you doing?
Well, I actually had a different sort of strategy because I was going for a score of 10. Now,
Ah,
I'd actually scored 10 in the first round. I don't know if you remember, but I scored 10 in the first round. And I thought,
exactly
that's
10,
it, I'm going to quit.
okay.
The second round, I didn't get to 10 exactly. So I had to keep going and I scored just over 10. But as soon as I got to 10 or more, then it was like, that's it, I'm going to bank it.
What did you score in the second round?
I scored 12 in the second round. I didn't
Okay,
score
but
anything
because
at
it's
all in
bigger
the
than
last
10.
round. Yeah, you're right. It's bigger than 10. So I just decided to stop.
Okay. So that's more, that feels like a better option than the roll strategy, because it is taking into account whether you've got a big score, because that's precisely how you're deciding whether to stop.
Yeah,
But why 10?
I think so. Well, honestly, because it's the first number in double digits.
Right.
I think there might be a better
True.
score to aim for, but I don't know what that is.
So we've come to the crux of this game, that there is a strategy which we're going to call a target score strategy approach, and it's a good approach, but what really matters is what's the best target score to aim at. And we could pick some extremes to sort of balance between. I think aiming for a really low score of 2 sounds like a bad idea. You could probably do better.
Yeah.
But aiming for a score of 100 before you bank is more likely than not going to end up with 0 most of the time. Now, you might get there, and if you do, you'll get 100 points. Great. But most of the time, I'm going to bet you're going to lose everything. So what we'd like you to do is collect some data on this. We'd like you to pick a target score and see what happens. And we're going to ask you to be quite precise. Don't change your strategy halfway through. Don't change your mind based on what your opponent, if you're playing against someone, is doing. And see what you get after aiming for a particular score for 10 turns. Any other comments, Kath?
No, I think the important thing to bear in mind is that because we're gathering data, it doesn't actually matter whether you end up choosing the best possible score or not, because you're just trying to gather data. And hopefully what you'll have the chance to do is to put that data together with your class so that you can see about which score's better. It might be that you have a little bit more time and you decide that actually what you want to do is to try some different scores. So you do 10 goes at, I don't know, aiming for a 10, and then maybe 10 goes aiming for a 12, and maybe 10 goes aiming for a 14 or something like that. So if you've got enough time to do that, then that would be a really, really good thing to do. But have a go, pick a target score, and then have about 10 turns, and then collect that final score. That's the thing that we're really interested in, is the final score after 10 turns.
Now, if we were doing this live, we'd actually be asking for your scores to be submitted to our database we're building of what's happened with this. This is recording, so we can't ask you to do that live, but the form we use to collect people's data is still live, and we've given that link to your teachers. So if you're interested in adding to our dataset, please submit your results to that dataset. I'll show you the graph of the about 1,000 people that have submitted data to that so far. We'll show you that after you've had a chance. But what you could also do, and depends on how you're watching this and what your teacher says, maybe you could collect your class data. So we've actually shared a spreadsheet with the teacher, a blank spreadsheet that you can put the score you aimed at and the score you ended up with after 10 turns of doing that strategy. And you could collect all those things and see a graph of what happens. Either way, we're going to talk about the results you get or that we've seen in the past in a moment. We think you should now pause the video and do the data collection. Remember, 10 turns, pick a target score, record the score after 10, and if you have time, do a different target score. Okay, Kath?
Okay, that sounds good, Ben.
Right, see you in a bit. Welcome back. I hope you've had a chance to collect some data on how different target score strategies work out for you. We'd love to see that data, and maybe you've submitted it to our live data collection. Great, thank you very much. Unfortunately, this is recording, so we can't show you that live data, but we can show you the over 1,000 entries we've had for data like this, which, because each one was for 10 turns, equates to over 10,000 turns of this game. Kathy, are you ready for this?
Yes, I'm ready.
Are you sure you're ready for this?
Go on, show me this graph.
Can you see the graph?
Yes.
So let me quickly describe what's happening. Maybe pause here if you're interested in just thinking about what's happening before I explain it. And now I'm explaining it because each number along the bottom is the target score that someone aimed for, and the number up the side is what they scored on average per turn. So, for example, if I get my laser pointer going on the 10,
yeah, I can
this
see
10
that now.
here, yeah, this 10 here was scoring just over 7 points per turn, which is weird because you're aiming for 10, but sometimes you're going to get 0 and sometimes you're going to get a bit over 10. And on average, it looks
Okay.
like it's settling down to just about 7 points there.
That looks about the same as the number 11 next to it.
Yeah,
Yep.
just 11 slightly worse, interestingly. And any comments about the graph, Kath?
Well, I'm going to be honest with you. I was kind of hoping that it looked a little bit smoother.
If it was settling down into a nice shape, we could begin to tell which one's best, but it's not obvious. Obviously,
Is
at the
that
moment,
because actually it's not that many people? I mean, would we want more than that?
I think we need more than that if this graph was going to be expected to be smoother. We could guess that somewhere around here is the best place to aim because 22 did best on all of our experiments.
Okay.
But there's lots of problems. I can tell you from looking at the data that the number 10, for example, the target score 10, clearly popular. 132 people tried that, and it's doing pretty well. But next to it, the 11, only 12 people tried that so far. So we haven't got
that might be why
amount.
the 11's less than the 10.
Maybe, or maybe that's why the 10's more, but it's not as reliable as the data we've got on the 10.
Okay.
And the 22 was a really good high score, but only 5 people have done that. So it's spiky, it's messy, probably because we haven't got enough data.
Do you suppose there is a possibility of maybe people putting the data in wrong, Ben? Could that have had an effect?
This is true with all data collection, right? I mean, you can type something in wrong. So maybe someone got a score of 10 and they went 100 by accident and put in a score of 100, which would drag up the average. It wouldn't matter too much if we had lots of data because that 1 point would get smoothed out by the rest of them. But if in some of these we've only got a couple of bits of data, and that would really be a problem. So it's very hard to clean up data. It's always necessary that when you've got real people typing in real data. And if you did type in real data, thank you very much. Keep it coming.
So Ben, is what we're saying that we're going to have to do this lots and lots and lots and lots of times just to be able to work out which is best? Surely there's got to be a better way of doing it.
I'm glad you asked. I mean, the reason we're doing this in a maths lesson is not just that we want to do lots of experiments, although we do, and that is surprisingly mathematical, but there is a mathematical way to predict what the best target score to aim at will be. Can I show you how that works?
Yes, please.
I don't think you need me to show you, but let's talk about it anyway. So, quick summary. I think the point of this strategy of this game is figuring out when to bank. And we've already established that waiting until you feel lucky or unlucky it's possible and you might do it anyway, but it's not a good idea. It's very hard to measure whether it's going to work. And also there's a problem with this number of rolls strategy I was talking about earlier because it doesn't take into account how much score you've got after a certain number of rolls. So your strategy of wait for a certain score before you bank seems better. The question is which score?
Yes.
So I'm going to look at an example score, 15 in this case, and ask you, first of all, should you bank, do you think, on a 15? Kath, what do you think?
I don't know. I mean, it was better than my one of 10, I think. So
you think aiming for 15 would be better than 10?
Well, I think 15 scored more than my 10 did, but
on that graph, I think it did. Well, here's two things that could happen next. If you bank, you're going to get 15 points. This is not rocket science, yes. If you roll, then two more things could happen. And these things are either you lose all your points.
Okay.
Which is if you roll a 1.
And that's why it's a 6, because there's only one sixth.
Exactly, one out of the 6 options. Or you don't lose your points. So, quick quiz question. What are the chances of not losing your points?
Oh, let me think. Is it possibly 5, 6?
Yeah, it's whatever's left. Lovely. And even more crucially, if you don't lose your points, you're going to score some points. On average, you're going to score, you can check this if you don't believe me, you're going to score 4 points on average. Can you see why?
You could score a 2, a 3, a 4, a 5, or a 6. So yes, the one in the middle is 4. Yes.
Indeed. The middle is the median, but also the mean in this case, and I'm glad we checked that. In this case, though, if you're on 15 and you score 4, then you are going to end up on 19 on average. Not every time, but on average. If you roll again on 15 and you don't go out, you're going to score 19 points. And these two options enable us to calculate what mathematicians call an expectation, which is a technical word.
Is this what you expect to get?
Exactly. It's a technical word meaning what do you expect to happen?
Yeah.
I'm glad you pointed that out. Sometimes the words in maths are confusing. Sometimes they're genuinely sensible. The expectation is a combination of the probability of something happening and the actual outcome itself. In this case, 1/6 of the time you get 0, and 5/6 of the time you get 15 plus 4, which happens to be 19. If you do that calculation...
15, sorry, Ben, you've put it as 15 plus 4 because we started on 15 and the average score each time is 4.
Exactly, and those two numbers are still visible in the calculation, which you'll see why in a moment. I wanted to keep them visible. I know it's 19, and so do you.
Okay.
If you do that calculation, you get 15.8 3, 3, and a few other
Oh,
numbers.
that's bigger than 15.
Bigger
So
than
does
15.
that mean that you should roll because you'd expect to get more than 15?
It's saying precisely that. If you roll again on a score of 15, you would expect on average to end up with a score bigger than 15, which in my head sounds like a good thing.
Yes.
So roll again on 15. The thing is, doing this calculation for lots of different scores is tedious, so we're going to do one calculation to rule them all, as Tolkien would say, and we're going to generalize. Because that's what maths is for. So we're going to do some algebra, and that's why I wrote it like this. Instead of using 15 in this, I'm going to use a value for any score. I'm going to use a letter. In fact, I'm going to use the letter X. The quick thing that turned up there is saying that this was telling me I should roll again because the thing on the left was bigger than the thing on the right, because it was 15.8 compared to 15. So now if I change that for an X, instead of 15, I use any score of X, I'm claiming I should roll again if that is true, if that left-hand side is bigger than the right-hand side. Okay. And this becomes a GCSE level inequality to solve. So we can forget the context and solve the thing. Yep. Help me out, Kath.
Okay, well, the first thing I would want to do is to multiply both sides by 6.
Okay, let's try that. So 5 stays there, and I get X plus 4 there, greater than 6x. Are you happy with that?
Yep, and then I've multiplied out the brackets.
I would too, so let's do that. I think that's 20.
Yep,
greater
and
than
then
6x.
I think I'd probably take 5 x's away from both sides.
Just going to get rid of it on the left-hand side, leave the 20 there, and we're going to get 6x, take 5x, which is 1x.
Yeah.
And I would want to kind of write that the other way around, which I can do, because as long as I spin the symbol, right?
Yep.
It's telling me that x is less than 20. What does that mean?
So you're going to roll again. Hang on. It says roll again if x is less than 20. So if any score less than 20, we should be rolling again because we'd expect the score to be bigger than the score we started with.
And any score bigger than 20, you should probably not roll again because your expectation will be lower than what you're on. Which means I think that 20 is the best target score because that's where it sort of balances out. If 20 is the best, then any score below that should give us an expectation of higher than itself, and any score above that should give us an expectation of lower than itself.
Can we try that with a couple of scores?
What do you want to try?
How about try it with 19?
5, 6 of 19 plus 4 is indeed bigger than 19.
And hang on, let's just check this. The 1/6 times 0 has disappeared because that's always going to be 0, isn't it?
Yeah, that was in the earlier calculation, but it is always 0. So you're right to point that out, and it has just gone because it's nothing.
Yeah, okay. So then if we check it with a score a bit bigger than 20, we check it with 21. And that is less than 21. So on average, we would expect to not be getting as much because we'd end up losing more times.
Yeah. On average, if you roll again on 21, you'll score an average of a bit less than 21, which is disappointing because you've lost points.
Yeah. And so what happens actually at 20?
Well, it should be the point where it balances, and that is the calculation. 5, 6 of 24 is 20. It's the one where it balances.
So if I scored a big number, because I'm thinking back to that graph we saw, there were some big numbers in there that did quite well. So how about something like 40 or something like that?
If you do 40, you expect to score, if you roll again on 40, about 36. Now, that's still quite a good score, but it is lower than what you were on, so you've sort of lost value. But if you do roll again on a high score, you will get an even higher score. So it does make sense that it's possible to do well on very high targets. But what this is saying is that on average, you're better to aim for 20.
Okay.
Now, this is all very well, but this is abstract maths, right? What we need to know is whether abstract maths predicts the real world. So I'm going to run a simulation, a little bit like the data we collected from 10,000 people who've been watching these recordings and joining these sessions. I'm going to run it with 100,000 that I've done on a computer. And it's not just 100,000 turns, it's 100,000 turns for each individual strategy. This took my computer a long time to run. I'm going to run it quite quickly. Let's have a quick look at the graph before I press go. This is after one turn, and you can see I've helpfully labeled the high points. So currently in the lead is a target score of 39. The person who aimed for 39 did really well.
So what this graph is showing us, Ben, if I can just check, is that after one turn of trying each of the strategies from 1 up to 40, this is the score that you got. So if someone was aiming for a 6, so when your computer tried to aim for a 6, it ended up on 0.
Yep.
But
and the
when
same
it aimed
up here.
for 14, it ended up with what looks like a bit more than 14.
A bit more than 14. And that's why it's kind of go off in line, but there are a bunch of gaps where they just failed. But we're going to run a lot more turns than that. So to cut this story short, let's just crank on this video. So I think I ran the first 20 turns quite slowly because it gives you a flavor of how spiky this graph is, a little bit like the data we saw before. By the way, the red and the blue don't mean anything particular. They're just alternating so we can see the differences. I let it speed up a bit after 20 because we have got to get through 100,000 of these. And you see it's already settling down a bit. It's even less spikier than our data. Some curious things going on. And 20 should be leading, right? But it's not. Data,
No.
right?
But then 22 did do quite well on the graph that we gathered from before.
Indeed. Now, the further you do this, what I would expect to happen is for it to go smoother and we'd see the peak where we'd expect to see it at 20. And it does look like 20 is in the race again. 21 is still beating it and 25 is doing surprisingly well.
No, 20's in the lead.
Oh, 25 just lost a bit of progress. 20's gone back into second place. We're at 75,000 turns, so only a few left in our experiments and it's speeding up all the time. And you can see at the end of our experiment, after 100,000 turns for each target score strategy, there's something of a relief. 20 did win. But only just. Any other comments on this graph? In fact, I will ask your comments, Kath, but let's give everyone else a chance. So if you want to, pause the video here and have a discussion about why the graph looks like it is. Is there anything that surprises you? Is there anything that you are interested to find out more about? Pause now.
Well, Ben, the thing that I noticed first of all was that the first two columns are the same height. And that made me think, because I wasn't sure why that was going to happen. So I thought, well, what's going to happen if you're rolling a 1? If your target score's a 1?
I mean, firstly, it's a really bad idea, right?
But... yeah. But if you're targeting a 1, then either you're going to roll a 1, in which case you score nothing, or you're going to roll the dice just the once, because as soon as you've done that, you've beaten the 1. And then I thought, well, what happens if you get a target of a 2, which incidentally is also a really bad idea. And if you roll aiming for 2, then either when you roll the dice, you get a 1, which means you score nothing, or you score something, but then you stop. So in fact, in both situations, exactly the same thing's happening. And that made me think, well, it makes sense they're the same height then.
And I'm relieved that our simulation produced that because I didn't predict it, but what you've just said makes a lot of sense. It's easy to see in hindsight when you see the data, isn't it?
Yeah.
One other thing to add to this graph is the graph. I got my computer to calculate what it should do if you run this forever. So the actual expected scores, it's actually quite a difficult calculation to do. You can go and investigate if you want. I had to write a program to do it, but it did spit out these numbers after a weekend of chugging through it. Literally, it was overnight on a Saturday night. It produced those blue dots, which I'm glad to report are pretty close to what we got from the real data. And even if we'd done this with real people, if we'd done enough of them, I'd expect our bars to sort of make that curve. There's a slight gap at 26, and that's also not too much of a surprise because real data is never perfect. The more you get, though, the closer it should match the expected data, as long as you've done the calculations right.
That makes sense.
I think we have, because it's even picked up that flat bit at the beginning.
Yep.
So I really love this. Mathematics can give you the predictive power to tell you, to say what's going to happen in an uncertain sort of world. And that's not just useful for games, that's useful for life. To test this, I would like to suggest we play the same game with different rules.
Yes.
So Kath, what rules are we going to do?
I would like to play not with a 6-sided dice, but with, I don't know if you can see this, an 8-sided dice.
Lovely, an octahedral dice.
An octahedral dice, can you see that?
It's a nice thing.
But the other thing that I'd like to change, if I can, is I want to change what you lose on, because I think only losing on 1 out of 8, bearing in mind that you could score up to 8 on a dice, so you can score higher each go. But then if you only lose on a 1, I don't think that's going to balance it out well enough. So I think I'm going to go for losing on a 1 and a 2. So if you if you roll a 1 or a 2, then you lose, but you could score up to 8 on each roll.
Right. So the real question is, target score strategy seems like a good plan, but what target score to aim for?
Oh, yeah.
Maybe you could score more because it's got 8 sides. Maybe you're likely to lose more because you've got more chance of losing. Do they perfectly balance? Who knows? Actually, we'd like you to have a guess. We're going to pause the video in a moment. The new rules, we're going to run a simulation after this pause. Have a guess now. And actually, if you're watching in a class, lock in that guess. Tell it to your teacher. Write it down on a piece of paper so you can't change your mind. And if you're watching at home, say it out loud, for goodness sake, so you're locked in. And we're just going to pause for you to have a discussion if you need to, and then we'll come back and show you the video. Welcome back. We are going to show you what happens if you do run a simulation of 100,000 dice rolls or 100,000 turns for each target score strategy on Kath's new rules. Kath, before I run the video, I mean, what did you expect to happen? I know you know what happens on this video, but what did you expect here?
Well, no, I'm expecting a target score of higher. We thought 20 last time, but you've got 2 chances. I don't know, maybe a score of 15 or something like that. So a bit lower than the 20. I mean, I know no one scored 15 on that, but then equally, I know just because somebody got 38, it doesn't mean that 38 is going to count that often.
Right, and this is just one term,
15. Right? Yeah, that's just after one term. I reckon 15.
So claim, if you had a prediction, claim that, make sure you can find that number on the bottom. They do go in order, so it's quite easy to find. And here's the 100,000 video for the new rules. The first 20 turns go slow again, and then it's going to crank up. 29 is not off the mark yet. Still, oh, there it goes. 29 has scored something finally. Not doing very well on average, though. Now we've got 32 in the lead, and 32 has dropped out. 39 was doing well again, but has faded a bit more.
15's not doing so well.
15, well, 15's not. It's close. It's occasionally on the podium. 16 was doing well. It's just backed off again. We've got a weird artifact at the beginning again. The first 3 are sort of stabilized flat.
3 columns. I wonder if anyone watching could have a think about why it's going to be the 3 columns that are going to be flat at the beginning.
25,000 turns now.
Oh, and 15. Look, 15 was in the lead for a minute there. Sorry.
You sound very pleased, Kath.
Yes, it's dropped off the podium now.
Halfway through our data there, you can see how much the graph has stopped twitching. There's tiny twitches going on, but they're not very big. That's what happens when you get lots of data, almost at the end of our experiment. And after 100,000 turns, first place is 16, second place is 17, so third place is 19, inexplicably 18 failed to make the podium, and so did 15, sorry Kath. But it does look like aiming slightly lower than 20 is better in this case. And if you want to go and do the same maths that we did on the D6 lose on a 1 version, the standard version, you should be able to find out whether 16 is what should have happened, and we'll leave that for you to go and have a think about. So maybe before we say anything else about this graph, another chance, pause if you want to, and make any comments you'd like to make about this graph. So the graph is almost a smooth shape. If I'd done more trials, I think in my simulation, it would be smoother. And there's this weird thing with maths, if you do things infinitely many times, then it'll be completely smooth, but you never can do that. What's interesting though is that even if I haven't calculated what the best target score is, I'm pretty confident that 16 is the best because I've done the simulation. And although it feels a bit like cheating, I just ran thousands of trials, genuine part of simulating the real world, sometimes you can't do the calculations, but you can do the experiments. And they call this a Monte Carlo method because it's like what casinos in Monte Carlo do to model what's going to happen in their gambling situations. You run it thousands of times to see what happens on average. And if you do enough trials, it's a really good way of modeling the real world. But it doesn't... Yeah.
Go on. I was just going to say, Ben, I think you're talking about the real world here, but if I was actually playing this game against someone to win, then I'm not certain that just doing the same strategy the whole time is going to work. Surely there's got to be some psychology in there. I mean, look, if you and I were playing each other, and let's say I was on, I don't know, we were doing a race, the first to get to 100, and
which is how you play one of these games, yeah.
So if I was on 20 and you're on like 90 or something,
yeah, good point.
Then I'm just, you're going to win next go. So I might as well just go all in because it is possible that I might win. So I think there's got to be some psychology in there as well.
I think this is a really important point, is that the abstract mathematical modeling sort of things is powerful, but it's powerful to use in the real world where it's more complicated. And you have to sort of upgrade the mathematical bit with knowledge of the real world, like how are other players going to play. So you'll be glad to know that's what some mathematicians have done with the real Pass the Pigs game. There is a paper published out there where they analysed what's the best strategy, bearing in mind 20-ish for our dice game was the best thing to aim for. How should you play even when you know the opponent is going to go for broke when they're close to winning? And they have done it, and they've upgraded the model, which is what mathematical modelling should be about. You keep upgrading until you have a good enough prediction for the real world, which is what taking maths further will feel like. You get further down the modelling cycle. We should talk about taking maths further. What choices do people have, Kath?
Well, probably today we've been using probability to think about some of the strategies, and things like probability is included in all of these options that you've got after GCSE. You probably got an idea about A-level maths, but A-level maths involves doing a little bit more pure maths, some mechanics, and then some statistics. And there's bits of probability and statistics there to do A-level maths. But you might not just want to do A-level maths. You might want to do A-level further maths as well. Ben, can you talk us about some of the things that are in A-level further maths?
I really loved doing A-level further maths, and I don't think I really loved maths until I started doing that A-level. But it's a second A-level in mathematics because the subject is deep enough that it can't fit into one A-level. If you do a further maths A-level, you could also do an AS level in further maths and just do a little bit, but you will study some brand new bits of maths. Things called complex numbers are exciting. I won't spoil the fun there. You can look them up if you like. Things to do with the square root of negatives. You'll also study some serious statistics and get a bit more of a handle on how we might do some of the modeling that we were doing on this game in more detail, in a more academic way. And you might get to do some other bits of maths. You'd also do some mechanics, but there's a bit of maths that you only get to study in further maths of applied maths called decision maths, which is basically the maths of algorithms. How does Google Maps know how to get from point A to point B without a human telling it that you should turn left up there? And how do you program a computer to do that sort of thing? I used it a little bit today when I programmed my computer to solve some of these problems. If you want to study algorithm design, then that's going to be in further maths as well. But then there is also a whole chunk of maths which isn't advanced mathematically, but does get complicated when you put it into the real world, which we've also been talking about. And that comes up quite a lot more in core maths. Tell us a bit more about core maths, Kath.
Well, core maths is a reasonably new qualification, and it's been designed to sit alongside doing 3 A levels or BTECs or diplomas and A levels. So whatever mix it is you're doing, core maths will sit alongside it. And the idea is that it will support the maths that you're doing in the subject you're doing. So, for example, you might be thinking, oh, well, what maths is there in geography? Well, quite a lot of the time, you'll be taking bits of data and then you'll be analysing them in context. Well, the core maths will help your skills with that. And of course, the same thing's true for chemistry, for BTECs like physical education, the social sciences and psychology. I mean, we've talked about psychology being used in maths. Well, there's an awful lot of maths used in psychology. So core maths will really support you in doing that. And it's well worth looking at studying it alongside the other subjects. As an added bonus, if you're wanting to go to university, then some universities will give you a reduced offer on your 3 A levels if you get a good grade in either core maths or further maths, not just the A level further maths, but the AS in further maths. So if you've got the opportunity to do either AS further maths or core maths, that might give you a lower offer on your other subjects. Very useful. That's something that's worth thinking about. And loads of this information is available at our website, which is on the page at the moment.
Well, so if I hope you've enjoyed the game today, go and figure out how you want to play Pig against other people. But if you have further questions, you can get in touch with us. Obviously, you can go to the website that Kath just mentioned, but our email address is on the screen now. You can ask specific questions about the game of Pig. If you put the subject, how much is too much in the subject line, we will know what you're asking about. Anything else from you, Kath?
I don't think so, but do get in contact with us if you want to. Thanks
very
much
much
for watching.
See you
Bye.
again.